Today we're tackling a problem that simulates navigating a file system. Given a series of log operations, your task is to determine the minimum number of steps required to return to the main folder from your final position. Can you find the most efficient way to track your depth? The problem, crawler log folder, provides an array of strings representing log operations. Each string is either go to parent folder, stay in current folder, or go to child folder. We start at the main folder, which is depth 0. Our goal is to return the final depth relative to the main folder after processing all logs. Child folders are always new, unique names. The key challenge is correctly handling moves up and down the directory tree. A straightforward approach uses a stack to simulate the folder hierarchy. We'd iterate through the logs. If we encounter a go-to-child operation, we push the folder name onto the stack. If it's a go-to-parent operation, we pop from the stack, but only if the stack isn't empty. Stay in current operations are simply ignored. Finally, the number of elements remaining in the stack is our answer. This works, but storing folder names is unnecessary. It results in an big O of n time complexity due to iteration, and big O of n space complexity in the worst case, as the stack could store all folder names. The key insight for optimization is realizing we don't need to store the actual folder names. We only care about the asterisk depth asterisk relative to the main folder. We can replace the stack with a simple integer variable. Let's call it depth, initialized to 0. When we encounter a go-to-child operation, we increment our depth counter. If we see a go-to-parent operation, we decrement depth, but only if depth is greater than 0, preventing us from going above the main folder. Stay in current operations still do nothing. After processing all logs, the final value of depth is our answer. This approach perfectly mirrors the stack's behavior for this specific problem by just tracking the count of items that would be in the stack, without the overhead of string storage. Let's trace this with the example. D1, D2, /D21. We start with depth at 0. First, D1 is a child folder, so we increment depth to 1. Next, D2 is another child, depth becomes 2. Then, / means go to parent, since depth is greater than 0, we decrement it to 1. D21 is a child, increment depth to 2. Finally, means stay in current, so depth remains 2. If we had another / right after, depth would become 1, and if we hit it again, it would become 0. But since we only have 2 levels of depth, we stop there. After processing all logs, our depth variable is 2. This is the correct answer, as it represents 2 levels deep from the main folder, which is the minimum number of operations to return to the main folder. You'll spot this pattern when you need to track hierarchical or nested states, like file system navigation or parsing nested structures, but only care about the current level or count, not the specific items. If the problem asks for depth or level, and operations are purely up or down, a simple counter can often replace a full stack data structure. This optimized solution has a time complexity of big O of n, because we iterate through the logs once. The space complexity is big O of 1, constant time, as we only use a single integer variable. This stack as counter pattern is highly effective. Try another problem that might use a similar approach. Don't forget to like and subscribe for more efficient DSA solutions.